So I fixed the geometry. We've got now a 3 by 5 grid of points here. We're going to be making the response measurement in the sample 8 location in the middle, and we're going to make excitation or impacts at all of the other 15 points in here. So we now can go to the channel setup sheet, which was where I was before. Can turn on, show the geometry up here, use this refresh button. I can right click on here and show the marker names, and they should, importantly, they should come through with the component first, which is sample, and then the location 1, 2, 3, 4, 5, 6, and so on. Right, so I said that I was going to make a response measurement at sample 8 there, so that's sample 8, and my response measurement is the LDV. So I'm going to select that row here, and I'll insert this one onto here. So the information particularly that's important is the point name, sample 8, it's now called in here. Okay, and I'm going to start making impacts from sample 1. So that's my reference, that's going to be my force transducer. I'll insert that onto there, so now this one's sample 1, and that one will automatically increment as we progress around the device. These are all making, they're only going to be making measurements, impacts and measurements in the Z direction, which essentially is out of the geometry, as you can see here, unidirectional measurements. The vibrometer measurement is a vibration measurement, and it's in volts. Okay, you can see if I hit this drop down, I can also select ICP. So for the force transducer, I need to select ICPE. That's an IEPE transducer. And once I select IEPE, you can see the indicator lights on the frame here below go from red to green. Normally, so I'm providing signal conditioning on this channel. It's actually still green at the moment. I wonder why. It should tell me that that's open. So, because I'm on volts, still on volts. If I go to ICPE in the software, now it goes to red. It's flashing, telling me basically that there's nothing connected because it knows it's not conditioning a channel. When I connect this, eventually it will power the transducer, and then it goes to solid green. If I break the cable, if it's a problem, goes back to red. So it gives me some indication that the measurement chain is good. It will also flash red on the acquisition system if I get overload, if I've got too much measurement from the transducer, and a range of other reasons. So it's useful to always keep an eye on the front end on the channel by channel basis. Okay, the measured quantity for the force transducer, of course, is force. I can get rid of the geometry sheet now and go just back to channel setup. Now I need to get my calibration certificate out from my transducer and specify the sensitivity. So 26.18 millivolts per Newton, and that's exactly what we're being asked to put in this box up here. So 26.18 millivolts per Newton for the force transducer. Now for the vibrometer, we're measuring velocity. So I scroll down for velocity, and for the vibrometer I've got 3 different settings. This is looking for a value in millivolts per meter per second. If we look at the vibrometer, I've got different settings on the vibrometer. So I can choose either 20, 500, 100 or 20 on the display by cycling through. I've also got a low pass filter, which can be either 1 Hertz or 25 or 22 kilohertz. So effectively 22 kilohertz is the filter off, low pass filter. High pass filter, yes or no. Importantly, we want to turn the high pass filter off. High pass filter is essentially 100 hertz with the PDV. If we had the high pass filter on, that would mean there would be no signal below 100 hertz, right? So I'm using an intermediate velocity range. Now this 100 is in millimeters per second, and the output for this device is 4 millivolts full scale, right? So that 100 essentially should be divided by 4 to give me a measurement 25 millimeters per second per volt. And of course, this is asking for millivolts per meter per second. So I probably need to get my calculator out at this point. And I've got 25 millimeters per second per volt. Okay, so I need to take the reciprocal of that. So that's 25 volts per meter per second. And I want that in millivolts per meter per second. So of course, times that by 1,000. That gives me a value of 40. Okay, so here, to get engineering units in my acquisition system, I should enter 40 millivolts per millimetre per second. Okay, I also have American units I can specify in inches per second, but meters per second I should say. 40 millivolts per metre per second. Did I do that right in that case? I said 100 millimetres per second, so that's 0.1 actually. Meters per second divided by 4. Turn that on its head. 40, I think I've got the same, that's in volts. I think I need actually to be in 40,000 to get to millivolts. Yeah, so it's 40,000 to get into meters per second. 40,000 millivolts per meter per second. I can use the accelerometer calibrator, which I showed in a different video, put that beneath the LDV, and that would give me a means by which I could confirm that I'd entered the right sensitivity for that measurement if I needed to. How many seconds have we been running? Because
6 minutes.
6 minutes. Okay, let's perhaps stop there and then we'll resume.